Welcome to the world beneath our feet, the unseen foundation of every structure. We marvel at skyscrapers and bridges, but it's the ground, soil, and rock that truly supports them. How do we ensure this natural foundation is safe? Through a unified set of rules, the Eurocodes. These European standards guide the design of buildings and civil works, ensuring safety and consistency. Eurocode 7, officially EN 1997, is dedicated to geotechnical design, how we build on and with the earth. In Germany, it's adopted as DIN ON 1997, the national version of this European rulebook. This standard allows engineers across Europe to speak the same technical language, using shared principles and safety concepts. Before Eurocodes, each country had its own rules, making cross-border projects complex and sometimes unsafe. Now, Eurocode 7 and DIN ON 1997 provide a clear, modern framework to prevent failures and ensure reliability. We'll explore why a unified code matters, break down DIN ON 1997's core principles, and see how Germany adapts it with national annexes and supplementary standards. Local geology and traditions matter, so Germany adds its own requirements. We'll also highlight why ground investigation is the essential first step in safe design. Let's dig into the details and discover how these standards keep our structures standing strong. The journey into geotechnical safety starts here. Eurocode 7's main goal is to unify geotechnical design rules across Europe. Imagine building a railway across countries with different foundation rules, confusing, costly, and risky. Eurocode 7 solves this by providing a single, harmonized standard for safety and performance. This makes cross-border projects smoother and encourages innovation and collaboration among engineers. At its core, Eurocode 7 manages risk, accounting for the unpredictable nature of the ground. It uses limit state design, ensuring structures don't reach a point of collapse or excessive deformation. This approach moves engineering from guesswork to science, raising safety standards everywhere. The harmonized code guarantees public safety and a consistent benchmark of quality. Eurocode 7 is the silent guardian beneath our infrastructure, ensuring stability for generations. It's the backbone of modern geotechnical engineering in Europe. DIN ON 1997. 1 is the core document for geotechnical design in Germany. It covers everything from building foundations to retaining walls and embankments. The standard introduces key concepts like limit state design, considering all possible ways a structure could fail. Ultimate limit states, ULS, address collapse, while serviceability limit states, SLS, focus on usability. Projects are classified into geotechnical categories based on complexity and risk, ensuring appropriate design effort. Category 1 is for simple projects, Category 2 for most conventional structures, and Category 3 for complex or high-risk works. The standard requires a ground model, an accurate representation of site conditions, built from thorough investigation. Design verification checks that ULS and SLS requirements are met, using different design approaches chosen nationally. This structured process ensures safety and reliability tailored to each project's demands. DIN ON 1997. 1 is the foundation of safe geotechnical design in Germany. Eurocode 7 isn't one size fits all. Each country adapts it through a national annex. Germany's DIN ON 1997 1NA specifies key parameters, like partial safety factors and preferred design approaches. These factors reflect German experience and ensure safety aligns with national standards. The national annex defines which design approaches to use for different situations, such as foundation or retaining wall stability. It tailors the European framework to Germany's unique geology and engineering traditions. Without the national annex, engineers would face too many open choices and potential confusion. DIN ON 1997 1NA is essential for compliant, safe geotechnical design in Germany. It's the bridge between European principles and German practice. Germany's engineering tradition goes beyond the Eurocode, preserved in DIN 1054. This supplementary standard provides detailed calculation methods and rules not covered in Eurocode 7. DIN 1054 includes procedures for settlement calculations, slope stability, and special cases like frost heave and earthquakes. It ensures foundations are deep enough to avoid frost damage and addresses seismic risks in vulnerable regions. DIN 1054 complements Eurocode 7 and the National Annex, forming a complete toolkit for German engineers. For a compliant design, all three documents, DIN in 1997, 1, the National Annex, and DIN 1054, must be used together. This trio preserves valuable national experience while meeting European standards. It's the detailed rulebook that ensures German geotechnical safety. No design is better than the data it's based on. Ground investigation is critical. DIN N 1997, 2 sets the standard for planning and executing soil and rock investigations. It details how to select investigation points, retrieve quality samples, and conduct field and lab tests. Tests like the Standard Penetration Test, SPT, and Cone Penetration Test, CPT, measure ground properties on site. Lab tests determine soil strength, compressibility, and other key characteristics. The German National Annex to DIN, enter 1997. 2 specifies preferred testing methods and national correlations. Standardized procedures ensure reliable, comparable data for every project. Thorough ground investigation is the first step in managing geotechnical risk. It's the foundation of every safe, economical design. Let's recap the Geotechnical Standards Toolkit for Germany. DIN N 1997. 1 sets the design principles, DIN N 1997. 2 governs ground investigation. The National Annex adapts the Eurocode to German conditions, specifying safety factors and design approaches. DIN 1054 adds detailed calculation methods and addresses national concerns like frost and earthquakes. Together, these documents form an integrated system from site investigation to final design. Mastery of this toolkit is essential for any geotechnical engineer in Germany. These standards are more than rules. They're a commitment to public safety and engineering excellence. By managing ground uncertainties, they prevent failures and ensure long-term performance. Understanding and applying these standards is the solid ground for a successful engineering career.